Hi everyone, this is Abhishek. Welcome to my channel, and today I'm going to introduce you to someone really interesting. This is DoDo. This is the robot which I made during my summer internship with Technophilia Systems. I can control it and program it myself. And today in this video I'm going to show you some of its working and programming. I always had this fascination for computer technology and robotics since I was a child, and today I'm going to share some of my fascination with you in this video. Now I'm going to dismantle it, split it up into individual components, and I'm going to tell you the significance of each component in the robot. So here we are. I have dismantled all the components, and now I'm going to show you each one and its significance in the robot. Let's start with the most important component of the robot. This is the microcontroller board. As you can see, it is comprised of many small parts, and I'm going to tell you a little about some of the main components in here. So let's start with this. This we have here is the USB interface, and here we have four sets of motor connectors. Each set has two pins, so this is total of four. Here we have the buzzer. These are some control switches. This is the LCD interface. This is the battery connector, these two, and this is the UART. UART is basically an interface between a laptop or any desktop computer and this microcontroller board. Here we have the Atmel CPU, and we have four sets of pins or ports on the board. The first is the A set, which we have here. As you can see, this small white LEDs, and the next is the B set pins. These are the C set and the D set. As we gradually progress the video, I'll tell you they're working. So let's move on. The next most important components are the sensors. This small chip you can see here is a gyro sensor. It's a 3-axis gyro cum accelerometer sensor. Okay, what it does is it measures the coordinates of 3 axes, mainly x, y, and z, and that the configuration of these axes can be used to control the robot. I'll show you the working of this in as we proceed through the video. This chip is a DTMF module. So DTMF stands for dual tone multiple frequency. As you must be knowing, dual tone multiple frequency is used in nowadays used in all of our mobile phones, cell phones. So basically, this is an interface between a cell phone's frequency and the microcontroller board. So using this chip, we can connect a mobile phone to the microcontroller board and control the robot using that phone. Now, this small chip you can see here is the infrared transceiver. It's basically a RC5 decoder, and this small black chip is the RC5 decoder over here. This chip can be used to transmit as well as receive infrared signals, and hence this can be used to control the robot using any infrared remote like the TV remote or the AC remote, and this can also be used to control infrared devices like the TV or the AC. Now this again is infrared transmitter. These two are the infrared diodes on the chip. Uh, this chip this can also be used to transmit infrared signals, and hence this can be used to control infrared devices. Like I said, maybe a TV or maybe AC. Now this chip is the RF transceiver. This is basically a CC2500 module. Uh, this can be used to receive as well as transmit radio frequency signals, and those signals can be received by other robots like this, and hence this is basically used for swarm robotics. Now this is a graphical LCD. Basically this is a smaller version of the graphical LCD. This can be used to display characters and numbers as well as uh, figures like maybe a circle or square or maybe a triangle. Now, coming to this is the main LCD of the robot. This is connected to the microcontroller board over here to the LCD interface. This can be used for various purposes like displaying various values for used by the microcontroller board, like the acceleration sensor values or the line follower values. These are basically called MPOS, which stands for multi-purpose optical sensors. As you can see here, here we have the connector to the microcontroller board, and this is the LED, and this is the optical sensor. Actually, its work is it's used for obstacle avoiding. It's used for avoiding obstacles, and it can also be used as we use the robot as a line follower robot. Here we have another very important controlling device for the robot. This is basically a normal resistive touchscreen. As we're done with all of the electronic components of the robot, now let's move on to the physical components. Uh, Here we have this is the body frame of the robot, and here we have two plates for this. One is the upper plate, it has two holes on it so that the wires can come out and can be connected to the microcontroller board. And here we have the lower plate. So basically after we fit this, the robot looks like something like this. And we have the two driving wheels which are connected to the motors, and these are the two supporting wheels which are placed at the front and the back so that it can support the driving wheels while they move. And here we have our motors. So basically this is a 1500 RPM motor, and it has gears inside which steps the speed down to about 60 RPM. And these motors are quite powerful, and they are used to drive these wheels and the robot basically to do all the work it can. And here we have all the screws, and this is what we have that powers the robot. These are basically 9-volt mercury cadmium batteries, non-rechargeable obviously, and they last for quite a long time. And these are connecting wires. As you can see, this is a UART wire. This is connected to a serial port, and the other end could be connected to the UART port of the microcontroller. And this is basically used for data transfer between the computer and the microcontroller. These are normal connecting wires, and we'll be using these wires to connect basically mainly all of the components, mostly all of the components that we have to the microcontroller board. And this is the other type. These are the battery connectors, and this is the DTMF module connector. Basically this is used to connect the phone, and this is connected to the DTMF module. Now coming to assembly of the robot. Here we have the main body frame. This is the lower part and this is the upper part. We have two motors. These motors are fixed in over here on like this, opposite to each other on two different sides. And then we put the lower plate over here, and this is the upper part. This is used for keeping the batteries. We keep the batteries over here, use the battery connectors, and then fix it here. We take out the wires, and then the microcontroller board is fixed on the upper plate. And after doing this, we fix the wheels to the outlets of the motors that come out from here. I'll just show you. So these motors basically come out from here like this, and we fix the wheels over here so that the motors will be able to rotate him. And then after fixing the microcontroller board, this is the lower plate, and we fix the supporting wheels over here so that they can support the movement of the robot. Now we are done with the basic assembling of the robot. Here what you see are all the basic components that are required for doing any specific task and any basic task by the robot. For doing other specific tasks like following the line or avoiding obstacles or maybe being controlled by a mobile, we would need different components that are fixed on this. Let's move on to specific tasks. I'll tell you what are the main steps before we perform any specific task on this robot. The first step is obviously to dump the code. As I've already written the codes and they are saved on my laptop, I don't want to waste time in this video writing the codes again and showing it to you. So I have the codes and let's dump it in. Like the first step to dump the code is I connect my USB to my laptop. Then the other end is connected over here, USB interface of the microcontroller, as I said before. So here we go. And as I showed you in the intro video, this is the programming switch. We put it on the programming mode. Then we dump the code. Basically, for C, embedded C, we have HD boot flash. This software is used for dumping the code into the device. We find, first step is to find the device, then we open the file. These are basic steps. So after we are done with dumping the code, we should know what are the specific components required for the task to be done. And after dumping the code, suppose we have a line follower code or an obstacle avoider code, we have specific components to connect it. And after we connect the components, we're done and we switch on the programming mode and power on the robot so that it will work. As I told you before, this robot can avoid obstacles as it moves. This can be considered in one of our specific tasks, which I am going to show you today. For any specific task, as I told you, the basics are: first, we connect the laptop, we dump the code in, then we connect specific components, and we're done. So as you can see, this is already connected to my laptop, and I have dumped my code, which I told I've already written them. So it'll be a waste of time if I show the writing of the programs again. So let me keep my laptop aside, and this is the USB cable. Let me cut it out. So as you can see here, these are two MPOS multi-purpose optical sensors over here. As you can see, it has one LED over here and one over here, and the other two, the black sensors, are the photodiodes. This task works on the principle of reflection of light, and these light emitting diodes emit light, and when something comes in front of it, the light gets reflected and it's sensed by the photodiode, and this is how it sends a signal to the microcontroller board and turn right or to left according to what the signal is sent. And this is how the basic principle of working of this task is. Only connecting the components to the robot doesn't do any work. The components have to be connected to the microcontroller board, and these cables are what we use for connecting the components to the microcontroller. As you can see, this has 3 wires in it. The first black one is the data wire, this is the positive wire, and the negative wire. So now I connect this over here, and technically I can connect these wires to like any ports. It depends on the program, what I write, how I initialize the ports and all, but according to the program which I already have, I have initialized port PC0 for the left sensor, and we have port PC1 for the right sensor. So we'll connect it accordingly, and then I'll show you the working of the robot. So here we have PC0 and PC1. Let me connect it. So the data wire goes into the data port. Just the color coding you have to see, and this is the same for it. And now we're done. You can see that we have switched on some lights in the room, and as I told you before, this thing works on the principle of reflection of light, and we've switched off the light so that it can work properly. So now let me switch it on. So it moves. Okay, so can you just see what's happening? When the left sensor comes in front of the screen, it turns to the right, because as this light is reflected from the screen, it gets sensed by the photodiode present on the right, and it sends a signal to the microcontroller board and to turn to the right. And now you can see that as the screen comes near the right sensor, light gets reflected from the screen, and it is sensed by the photodiode on the right sensor, and it sends signals to the microcontroller board to turn left. And this is basically how it works.
Well,